In this video, we'll solve and discuss Cauchy Euler equations. Second order Cauchy Euler differential equation is of the form ax squared y double prime plus bxy prime plus cy equals 0. The type of solutions that we are looking for are y of x equals x to the r, where r can have one of these possibilities. If R1 and R2 are real distinct solutions, then the solution is of the format y of x equals c1 x to r1 plus c2 x to r2. R1 equals R2 equals R, which means real and repeated. Y of x is of the format c1 x to the r plus c2 x to the r ln of x. And then if R1 and R2 are two complex solutions, they will have the form a plus minus bi, where a is the real part and b is the imaginary part. Then y of x is going to be of the format c1 x to a cosine of b ln of x plus c2 x to a sine of b ln of x. Why do we have this R1 and R2? Because once we replace y of x and its derivatives into this equation, we are going to obtain a second order or second degree characteristic equation. If we have higher derivatives, we'll get higher degrees of the characteristic equation. So let's take a look at the problem below. X to the third y triple prime of x plus 9x squared y double prime of x plus 19x y prime of x plus 8y of x equals 0. So we are looking for solutions of the form y of x equals x to the r. So let's do all the derivatives. So y prime of x equals r x to r minus 1 using the power rule. Y double prime of x is r times r minus 1 x to r minus 2. Y triple prime of x is r times r minus 1 times r minus 2 x to r minus 3. So we are going to replace all these derivatives into equation star, and we obtain the following equation. X to the third r minus 1 r minus 2 x to r minus 3 plus 9x squared r times r minus 1 x to r minus 2 plus 19x r x to r minus 1 plus 8x to the r. Now we notice that x to the third times x to r minus 3, it's x to the r. X to the second times x to r minus 2, it's x to the r. X times x to r minus 1, it's x to the r. And then we have a factor of x to the r. If we factor out x to the r, we obtain x to the r times r times r minus 1 times r minus 2 plus 9r times r minus 1 plus 19r plus 8. So, if we set x to the r equal to 0, we are going to get x equals 0, which is going to give us y of x equals 0, which is the trivial solution. So now, let's take a look at this equation by first opening up all the parentheses and adding like terms. We obtain a third degree equation that has the form r to the third plus 6r squared plus 12r plus 8. This is the characteristic equation. So now we want to solve this equation. The way we'll do it is we're going to look for possible solutions through the factors of the constant, which is 8, over the factors of the leading coefficient, which is 1. So basically, plus minus 1, plus minus 2, plus minus 4, plus minus 8 are possible solutions. So let's try one. Let's check and see what happens if r equals negative 2. If we replace this in this equation, we are going to get negative 8 plus 24 minus 24 plus 8. So we can see that we get 0. So our first r, let's call it r sub 1, is negative 2. In order to get the other ones, I'm going to use synthetic division to divide our polynomial that by -2. So the coefficients are 1, 6, 12, and 8. We copy down the 1 and we multiply and we add. So we get 4. We multiply and we add. So we get 4. We multiply and we add and we get 0, which is expected when r equals -2, it's a solution. So the new equation, it's r squared plus 4r plus 4 equals 0, which is actually r plus 2 squared equals 0, which means r equals -2. So in other words, we actually got twice. We actually got r equals -2 repeated solutions. Repeated solution with 3 times, right? So what does that mean? It means our solution y of x is c1 x to -2 plus c2 x to -2 ln of x plus c3 x to -2 ln squared of x. I hope this helps.